या मेरी आवाज आ रही है? Am I audible?
अभी आ
Okay.
रही।
If I'm audible, it's fine, right?
हाँ।
So again, today's agenda will include this four discussion for the first four questions probably. Okay. So like without wasting time, let's start. Okay. Yeah. So moving on to the first question. If you get any doubts, you can pause me in middle, or it will be better if you ask after discussion is over. Okay.
ठीक है, ओके।
So the first question states here: in a cricket match, the retiring of three batsmen with three consecutive balls is termed as a hat-trick. Fine. A, B, C, D, E, F denotes the batsman's score for each ball in the okay. Each of the variables can be integer less than equal to 6, denoting the run scored by the batsman or denoting a wicket. Okay, so this is quite an easy question, nothing to be discussed here, right?
हाँ, easy। मतलब इजी है तो कुछ बहुत टायरिंग।
So yeah, nothing to be discussed here. I'm sorry, I think there was net issue in the middle. So yeah, I think this is fine, right? If here
हाँ
just
हाँ,
we need to check three consecutive balls have W or no for a hat trick, right? So here if you see, so like yeah, one two, we don't have three consecutive W, right? There's no hat trick. Here we have three consecutive W, so we have a hat trick. Here we have three consecutive W, so we have a hat trick. Here again no three, so hat trick. So this is quite easy, correct? Nothing to be discussed here much. How to write the code? We can just write a simple for loop. If I write in rough, write the code roughly. Roughly the code will look like this.
ठीक है
Okay.
ठीक।
Okay. So second, yeah. So let's move to the second question. Here the question says step is a visitor in CodeChef's new office. Fine. All doors inside the office require a swipe. Okay, fine. The access card allows a fixed number of swipes and expires after that. Fine. You're given a binary string s of length 10 and an integer x. Fine. Si denotes the swipe of access card. Fine. Okay. Then reducing the remaining swipes by one. Okay, fine. We're going to renewal access card. That's the okay. That's okay, fine. Find whether the string s okay. Where the card never expires. Okay. Access card zero swipes left in the beginning. What do you mean by this statement? Zero swipes left in the beginning. In the beginning, we have zero swipes left. Simply. That's if we see the constraint, right? Here in the input we get initially two integer n and x, and this is okay, fine. And x is the number of swipes left in the access card after renewal. Fine. And okay, fine. So zero triple one, right? So initially card is zero swipes, then she would not be able to access the first store. Yeah. Or we'll see for the zero means what do you mean by zero? Zero means he needs a swipe for opening the store, but initially you have zero swipes left. That's the question the last line says, right? So in this case, it's not possible. For this one, okay. So initially we have it's swiping, right? So we set the number of swipes to x. X is nothing but 2, right? Now we are using one swipe, so 2 gets 1. Using one more swipe, it gets 0. Now again 1, so we set it to 2 again. So it's possible, right? We can access all the doors with a given x. Basically, if it's 0, then you have to reduce from minus 1. Initially, swipe is a variable with 0, okay? Now in a string, if you encounter a 0, then s is equal to s minus 1, right? And if s after this operation is less than 0, then no, straight away, right? If s is not less than 0, it's fine. And okay, this is for when the string encounters a 0. If the string encounters a 1, then s is equal to x. straight away. Whatever may be the value of s at that time, it's straight away equal to x. We can continue in this manner, right?
हाँ.
If I think this is clear, right? Nothing here. And if you want for the coding part here, now this we can code. It's very easy if you don't commit any mistake. In and then x scene and scene. Okay. And here we take the string s, right? And in answer variable equal to initially zero size, correct? What should we do? See it over the string, correct? And let's see the variables. If s of I equal to, it's a binary array of string or what is it? String. Okay. Yeah. If s of I equal to zero, then what should we do? If it is one, then answer should be equal to x straight away. As what? Answer equal to answer minus one, right? Now, if at any time answer is less than zero, then what should we do? Then we should see out, see out, no, and break out from the group.
Continue.
Or
अच्छा नहीं, हाँ, break.
we have to break out. So we can set some flag go to false and break out. Okay, we can have a variable flag here. Okay, and yeah. So at the end we can see if flag is still true, then let us see out what. Yes. Okay. Else we can just continue. Else can just continue this, right? This works fine. Is this answer? Yeah. So quite a simple question. I think we don't have any doubt here. Just we need to read the question and follow the instruction. We get our answer.
Hmm.
Going on to the third question quickly. Many folks complained that the class is taking too much time to get over. Today we'll finish it fast. You're given an array A and B of size n and m respectively such that, okay, each value in B is between 1 to n. Fine. Okay, for each I, okay, from 1 to n, fine. Sort the suffix of length bi in array A in non-decreasing means increasing order, right? In the sorted order, basically. Okay. What do you mean by suffix? Suffix means the last part of the array, right?
Last part of.
Okay, fine. Output A after all operations. Fine. Okay. Here, if we see, right? So we have two array, right? One is 2, 3, 4, 6, 1, and one array is simply 2. What's our requirement? We go here. We see it's 2. So we sort this part, right? So 2,
Hmm.
3, 4, 1, 6. Now no more operations here. So this is the final answer we get. You see in this case, right? What do we have? We have this array, right? We go one by one. So we go first element is 1. So we
One.
sort this array, last one element. So it's nothing to be
Hmm.
sorted there. Now 2. Last two element we need to sort. So it's 10 and 13, correct?
Hmm.
4. Last four elements need to be sorted. So it's 5, 7, 10, 11, 12, 13, correct?
Hmm.
Suffix means that number of elements from the end. Just you pick
Hmm.
that and sort that, right? Okay. Now let's see what's the time complexity needed here. The intended time complexity
Or
here. If it
simply we
okay.
can just see the maximum in BI.
Okay, like if we try to say, like see the brute force, right? In brute force we see each element and we try to sort that part of the array, which the worst case can be square and square, right? And here we can see n is 2 into 10 to the power 5.
5.
That's not feasible. Now if we try to use some tricks and something like that, then we see, let's say we have an array, a big array, correct? And elements. An array B contains its three elements A, B, C, D. Okay. Now what let's say what do you mean by this? Short D, last A element, correct? What do you mean by this? Let's say B. And B is greater than A. Short D, last B elements, correct? Correct? Let's say C is somewhere
हाँ,
between
हाँ,
A and B.
correct.
Short these
Correct.
elements. That's
Correct,
already
correct.
sorted. You getting my point? See,
Hmm.
first A. Let's say A is 10. Let's say this is 12. This is 11. This is 6. Okay. Let's do this. Now, what do you mean by this? Sort the last 10 elements, correct? 12. Sort the last 12 elements, right? This 11. Sort the last 11 elements. Sort it here. That's by default sorted, right? Because we have done this thing.
Hmm.
We have done this thing. 6. Sort the last 6 elements. That's by default again sorted because we have done this. So here we have everything sorted. So this part is already by default sorted, right? So what do you observe here? Just see the
Simply we
biggest
can
element
just
in this array
see the biggest and then
and sort that part of the array. Because
that
after that,
automatically it will be sorted.
everything will be sorted automatically. Because once the biggest element comes up, if we have sorted this array till the biggest element, then whatever comes will be in between this sub-array of the sorted array. Whatever comes after that will be in the sub-array of the sorted array, so we don't need to worry. And
Hmm.
you say whatever comes before that, okay, whatever comes before that, see, since we have chosen the biggest element, whatever comes before that, that's also a sub-array of the sorted array.
So variable.
You need to, like, so you don't need to worry. So just see the biggest element and sort that. And if you ask how to code this one also, let's code. Since you're coding all the questions for today, again, it's easy, I think, right? Just assist me if I'm wrong somewhere. We take an input as the size of both the array, right? C in N, C in M, right? And A of N. I don't think we need to take the second array, right? Because we need a greatest element only, right? So that we can calculate on the go. We don't need to store the array, right? And you can take the
Uh,
max element as 0. And run this loop first and int x, C in x. And what should we do? Max equal to max of comma x, correct? Now we have to sort the last max element of the array A, correct?
तो sort A plus max A or
So
N.
let's try to think this in 0% index. Okay, we need to sort, let's say, last three elements, let's say here. What do we write? If we need to sort this thing, then A plus
A plus
2, 2 to
2.
n, right? So we need to sort last three, so we write A plus 2. We need to sort last four, what do we write? A plus 1. Basically, it's nothing but n minus maxa.
N
Got it?
minus max A.
So that's it. So if we write it here, code, we can just do the sort function, sort A plus maxa minus n, correct? Say A plus n.
Hmm.
Am I right? And it just see out this array. Okay, and here we tried and it looks good, right? Okay, what is the issue? Maxa, A plus maxa minus n. The maximum value of maxa can be n, right?
N minus max है ना अच्छा नहीं हाँ max हाँ N minus
No, no, no,
max
it's n minus maxa. I'm so sorry. Yeah, I'm so sorry. Yeah, so here, is this correct? I think we're giving extra
correct
spaces.
correct
We don't need to leave space or what? System this. Quite a simple question again. Go to this one. This one looks promising. Yeah. So let's quickly solve this question. The question says, a chef has a special interest in studying set of integer. Fine. Given an integer n, he defines a code set as a set of distinct non-negative integers such that the sum of integers is in the set is equal to n. Fine. The product of each non-empty subset of the set is odd. Okay, fine. Determine. Okay. Basically, you know an integer n, right? The question is given only n, right? So okay, for n you have to define the number of distinct size of good set that can be. Okay, so how many different sized good sets possible? What is a good set? A set in which all the integers equal to n and the parent is odd. Now let's think on this. Okay, when can the parent of all element be odd? When at least one element is odd, or one element is not odd. What do you think? When at any number, right? Any number, right? X. If you
Ah,
multiply that by two, it's even. Any number.
even. Hmm.
So if you are multiplying a 10, 15 element set, and we have one even element, because even element contains the digit 2 in it, right? Even number contains digit 2 in it, right? So if you multiply x with 2, any number with 2, that's even. So we want the entire sum is odd. That means what? We want the entire product is odd. That means there should be all odd elements, correct? If the set contains all odd elements, then it's possible. Else it's not possible. Am I correct? Are you getting my
Ah,
point?
all odd elements.
Yeah. Now let's see. 4, right?
Ah,
Okay. So we want the sum of all elements of the set to be 4 and the product to be odd. How can we break it? So one breaking this possible, right? 1, 1, 1, 1. Set sum is 4 and product is odd. But yeah, this is one possibility I believe, right? Okay. But one more thing. The question says this is a set. So we cannot have any element as equal, right? The question says distinct set. So set cannot have any equal elements, right? So 4. So if the first element is 1, the next element has to be what? 3. Correct? This
hmm.
is the only possible set. If you see 1 plus 3 is 4 and 1 into 3 is odd. Let's say 18. Let's think of it. 1 is 1 comma 17, right? 1 comma. Okay. Now if you try to break 17, okay. 1 comma 3 comma 13. Okay, 13, right? This also makes sense. More. 1 comma 3 comma 5 comma. Okay, wait. 1 3 13 doesn't make any sense. Why? Because we have to make it 18, right? This 14 cannot possible, not possible, right? So this is not possible. 1 3 5. This is possible again. 2 1 17 1 3 5 9. This is also product is odd, and I believe the sum is also 18. Correct? One more. Can we expand it more?
Oh, oh, three, three,
Hmm?
three.
Can we
Oh,
expand it more?
because the one 3 5 is already there. 7 and 2 cannot be there.
Yeah. So and even if you try to make this 7, right? This is your 10. Like here, if you try all the PNC, nothing will work. Yeah. So yeah, in this case, two are possibilities, but now we have to think a device solution that it will work for all the cases. Here, if you see n can be 10 to the power 18. Okay, we can have a huge number. Now, what should we think of? Any idea? Let's try to think of all two sides set. Okay. If you have a number which is even, okay. If you have a number which is even number, correct? You have to break it into two parts. If you want to break this number into two parts, so is it possible to break into two odd parts? Yeah, it's possible, correct?
Yeah,
It's possible
possible.
to break into two odd parts, right? So basically, one thing, if the number n is even, then we can have set of size 2, 4, 6, 8. Are you getting my point? If a
Mm-hmm.
number is even, then we cannot have set of size odd. Why? Because if we have a, let's say if a number is even, right? So if we make a set of three elements A, B, C, then what's the condition? A, B, C should be an even number, correct?
Mm-hmm.
So Okay. If and we know A, B, C are odd. A and B and C are individually odd because the product
Individually
have to
or
be odd. So for odd product, we need every number as odd. Just now we discussed. Now if they are individually odd, so is it possible to multiply to add up three odd numbers to get an even number? No. To add up
nine
three odd numbers, never possible to get an even number. That's
even
why
number.
we know if n is even, then we can have set of size even 2, 4, 6, 8, and whatever, right?
Mm,
And if n is an odd number, then we can have set of size 1, 3, 5 continuous, and the
three
same
five.
logic goes here also. Okay,
Same logic, huh?
now clear. Now we have to think of how to think in this manner. Okay, let's try to think of. Now see, any number, it's any number. Let's say we have any number. Let's say we have a number 50. Okay, 50. Okay, a common thing, right? Now number is even, so we can have set of sizes 2, 4, 6, all those things, right? Now let's say a set of size 2. There are many sets possible. 149 is a valid set. 347 is also a valid set. The gist of saying is it's possible to have a set of size 2. It's not an issue, right? To have a set of size 2, it's possible, right? There are many possibility. 149 or 347, 545. We have many possibility, but it's possible at the end. Am I
Fine.
correct?
Ha ha.
Having a set of size 2 is possible. There are many sets of size 2, but we need to say how many different sizes are possible. So size 2 is possible, obviously, right?
Different sizes.
Now we can try for size 4. Okay. See, how to check whether size is possible or no? The logic is right. 1, 3, 5, 7. Let's say we add this. For what do we get? 16, correct? Now I am saying if adding these four elements is 16, so we can adjust any element in such a manner that we can get 50. Can we adjust? I think we can adjust. Right? We can adjust, right?
Ha.
Because a set of size 4. See, any set of size 4, what's the minimum sum we can have? In any set of size 4.
For any size of size for
What's the
distinct
min?
elements.
Huh?
हाँ तो
What's the
वन प्लस टू प्लस थ्री प्लस नहीं
odd elements, right? So
ऑड
minimum
एलिमेंट.
it can be 1357 minimum.
हाँ मिनिमम वन
So
थ्री
if the
फाइव.
minimum sum is 16 of size 4 and we want a sum of 50, so we can make it 50 by adjusting any element, right? That's on our us. We can make it. It's not impossible to make. That's my point, right? Let's now discuss set of size 6. So what are the elements? Minimum 9 and 11, right?
नाइन
If
एंड
we
इलेवन.
add it 36, it's also possible. Like how we can adjust, right? Let's say we have to make it 50. So what should we do? We can make any number else. Let's say we can just increase this number. Nothing. 4, 4, 9, 16, 25. We can make it 25, right? It's obviously possible, correct?
पॉसिबल.
Set of size 8, 11, 13, 15, right? Not possible because the sum will be 64. Is it possible? Is it possible? No, correct? So you're getting my point. What I mean to say here, right? Am I clear to my point? We are saying since we need to make a set whose sum is equal to n and where each element is an odd element. So we found out, okay, if given number n is even, then the set can be of sizes 2, 4, 6, all these things. If n is odd, then the set can be any of odd size. Now we discussed that, okay, to see if a size of a set is possible or not, what we do? Okay, if size 2 is possible or no, if size 6 is possible or no, we know the minimum sum is 1, 3, 5. The minimum elements in the set can be this. If their sum is less than n, if their sum is,
लेस देन एंड.
so we can have this size because how? We can just increase the last element to n minus this sum, right? It's always possible. Now, how to find out how many different sets are possible? Now we cannot do this like because n is 10 to the
Simply
power
we
18.
can अगर for even we can have
Now we
n
know a
and
trick, right? What do we know? We know that
sum
sum
of
of
n
these elements, right? Odd numbers is nothing but n square, where n is the number of odd elements. Like 1 plus 3. How many odd elements we have? 2. So it's 4. 1 plus 3 plus 5, right? How many elements are there? 3, right? So 3 square is 9, right? 1, 3, 5, 7, 9. Sum. How many elements we have? 5. 5 square is
5.
25. You add it and check, right? So what can we check? And we know we need to find out a set, right? Whose sum of all the other elements is what? Less than n, given n, right? Let's say this is capital N, right? So let this sum be small n square.
And
The small n square is greater than capital N, so n is less than root n. Right? Less than or equal to, correct? For example, let's test out here. It's 4, right? So n is what? Less than equal to 2. Size of the set can be less than or equal to 2.
2.
Now you know these are the possible sizes of the set, right? And we know both odd and even size is not possible. Only one type of size is possible. We know this thing, right? And since we have this is 4, right? What size? 4 means even. So only two. One even number we have. Up to 2 we have one even number.
Even
Correct?
number.
Again this one. 18. So it's n is less than equal to root 18. And since it's 18, so we can have only even size sets. That's what we discussed. Okay. What is equal to root 18? Tell me. It's nothing but 4 point something. So we have 1, 2, 3, 4. Four numbers possible, correct?
What number
And we
possible?
have to find out all the even numbers because n is even. So even number are 2. Understood? Understood?
Understood. Understood. One.
We can code this, right?